Hello guys, in this video we'll build a desktop app weather app clone using Tauri. We'll use SvelteKit for frontend and Rust for business logic. We'll also explore a free weather API. So let's begin. First of all, let's add our project. So open your terminal. I'll be using Yarn as the package manager for this tutorial. So if you don't have Yarn installed, I'll drop a link in the description depending on which OS you are using. First of all, make sure to install Yarn. So once you have Yarn up and running on your machine, we'll just do yarn create svelte, which will add the svelte project for us. Now here it asks where should we create your project. For current directory, we'll just enter and directory empty. Now if you need a demo app or a library project, you can select, but I'll just need a skeleton project, so I'll select a skeleton project. And yes, we'll be using TypeScript syntax and then ESLint. So that's it, and our project, as you can see. Now we'll need SvelteKit in SSG mode or static site generation mode. So for that we'll add a dependency, which is yarn add dev dependency svelte.js adapter static. So once the dependency is added, we can close our terminal, readme, and now we'll move to svelteconfig.js, and here we'll update the import from adapter auto to adapter static. Now we need to disable SSR or server-side rendering and enable pre-rendering. So we'll move to our project, and in SRC, in routes, we'll add a file which is index.layout.ts. Now if you are not using TypeScript, then .js, and then here we'll export const pre-render as true and export const SSR as false. This will disable server-side rendering and enable pre-rendering. Now let's add our Rust project. So open your terminal. First of all, we need a dependency for Tauri CLI. So we'll add a dev dependency, Tauri apps CLI. And once the dependency is added, we'll just do yarn Tauri init. Now here for the app name, we'll just use the default app name weather app, window title weather app, and here we'll just do build. And now the default path for the dev server, so 5173, and the frontend command npm run dev, npm run build, and that's all that we need for our Rust project to be added. First of all, move to cargo toml file where we need a few dependencies. So with Serde.json, Serde Tauri will add request to fetch latest weather data and features as JSON and blocking. And then we'll use .env to read environment variables. So let's move to main.rs. Now before we start adding our Tauri commands to serve data to our front end, let's go ahead and get an overview of our weather API so you guys can also sign up for the free API, and let's observe the response so accordingly we can design our model as well. So open your browser and head to weatherbit.io. It's a weather API which is paid but has a good enough free tier which you can use for development and testing or similar learning purposes. So you can just sign up with your email, username and password. It does not require any payment options or any credit card details to sign up. There are different weather APIs that you can check, but we'll be using hourly historical weather. So this is how the base URL looks like. It supports the get method. So API key is required, which you can only get once you sign up, and start date and end date are required parameters, whereas your time zone, language and units are optional. So these are the endpoints, which is get history by latitude, longitude. History is basically the weather info by city name, postal code, city ID, and we'll be using the one which is recommended, which is by latitude and longitude to be exact and accurate. And this is the example request, and this is how the example response looks like. Now it's a huge response which with lots of fields. It's a very rich API, I would say. It provides you all the details you need for a good enough weather app with every little bit of details that you want. But we'll be using some of the fields, not all of the response. So as you guys can see, it has temperature, it has feels like temperature as well, which is apparent temperature, and then also provides you description, which is like clear skies, sunny, rainy, or whatnot, and also provides you cloud percentage, precipitation, and visibility. So we'll be using some of these fields and we'll build our weather app around this. Back to our IDE, open your project explorer, and in the Rust project in SRC, add a model.rs. Now here we'll add our model based on the response that we just visualized and the fields that we want to consume. So pub struct response and derive, serialize, deserialize, and then we'll add pub city name as string, pub country code as string, pub data as vector of data, which we'll add in a minute, and pub time zone as string. Then we'll add the weather data struct, pub weather data, and derive, serialize, deserialize. So weather data, and here we'll just add pub dead time as string, pub temperature as option of F64, and apparent temperature or feels like temperature as option of F64, and weather as a weather, which we'll add in a minute to fetch description, visibility as option of F64. Now you can add more fields if you want, but I'll just stick with these fields, and then we'll just add pub struct weather, where we'll just take description, pub description string, and derive, serialize, deserialize. So we have our response model, and we have a weather data and weather. With all these fields available, we need a flatten object because we want to send or render our front end with flatten object, which is easier to parse for front end. So we'll just add a pub struct weather info, and here we'll just add derive, serialize, and debug, pub time zone as a string, pub city name as a string, pub country code as a string, pub dead time as a string, pub temperature as an option of F64, pub and apparent temperature as option of F64, and pub description as string, and pub visibility as option of F64. This is the flatten object that will return to our front end. So we have weather info, we have weather and all things. Now let's add an impl to add a helper function to basically you can say change or parse our response to weather info. So we'll just say impl response and pub fn to info self, and it returns a weather info. Now here we'll just select the first one because the history returns the data for all the hours between two dates. So we'll just select unwrap, and let's add weather info. Let's set all the fields. So you can also call different APIs to get whatever the data you want, but I'll just stick with the hourly one and just render the first one for now. Clone, and similarly self dot city name dot clone, self dot country code dot clone, and self dot data. Actually, we don't not need self now, we need the first one, and first dot temp dot clone, first dot apparent temperature dot clone. Similarly, first dot weather dot description dot clone, and first dot visibility dot clone. So this is the slim object that will return to our front end. This is all the model and the helpers that we need. So as soon as our user opens our application, we want them to see a list of countries, and they can literally select any country and fetch weather details for that. Now to make it possible, go to the project explorer, and in the Rust project add a data directory. Inside add a geo.json. So here is our geographical data with country name, latitude and longitude. Now I just selected 20 random countries from the world. You can add more countries if you want. I'll drop this data in the description so you guys can use as well. Now we'll be using, as I mentioned in the start, the API to fetch weather info by latitude and longitude. If you want to skip this step, then you can just provide a text box to your users on the front end, and whatever the country or city they type, just query by that. Now let's move to model.rs, where we'll add one final model, which is geo struct geo for geographical data, serialize, deserialize, and pub country as string, pub latitude as f64, and pub longitude as f64. Now let's move to main.rs and add our Tauri commands. So the first one is get geoinfo, which returns a vector of geo. So it's a Tauri command, and here we'll add let data fs read to string. So our path to the data directory and the geo.json file. Enable to read from file, and let mutable geo info vector geo SvelteJSON from str and data dot unwrap. Now since you guys can see our data is not sorted here by country name, so let's quickly add a sorting here. Geoinfo dot sort by a b, and a dot country dot compare, and b dot country, and then we'll return the geoinfo. Now before we add our second Tauri command to fetch the weather info, we need our API key. So move to the project explorer, and in src Tauri add a .env file where we'll add our key, and this one you can fetch after you sign up from the weatherbit.io, and then set here. So once you set your key, now let's go ahead and add our second command to fetch the data. So async fn get weather, since it's a network call, let as latitude, which will pass from our SvelteKit UI, and long as f64, and it returns the slim weather info object that we added, and it's a Tauri command. Then we'll just do .env .ok, and let key environment variable key, and expect error reading key in case the key is not set properly, and we'll just set our URL. Let me quickly add. So this is how our formatted URL looks like. We are using /orly history and passing latitude, start time, end time. I'll just add constants for start time and end time for now. And let's go ahead and send the request. So we'll just do response client now get URL send await unwrap JSON and parse to response, and we'll just do await unwrap. Then we'll just do let data response dot to info, which is the function that we added to convert this hierarchical object into the slim object that will return to our front end. And finally, we'll just say data. Now we can add a print here as well if you want to log the data to see how your data looks like, the slim object. This is all we need to add our Tauri commands. Now let's add our Tauri commands in the handler, or invoke handler, Tauri generate handler, and we'll add both get weather. Let's copy so it's exact get weather, and the second one we have is get geo info. So that's all for our business logic and the Rust code. Now we'll move to the front end side where we'll add our component or the SvelteKit UI. So for the front end, we'll shift to VS Code for a better Svelte support. First of all, we'll add a dependency, Tauri apps API, to invoke our Tauri commands from Svelte. So once this dependency is added, go to the extensions in VS Code and search for Svelte for VS Code and make sure to install this extension. Then move to the Project Explorer and in your src in the lib add a weather.svelte where we'll add our component to interact with our Rust code. So let's begin. First of all, we'll add a script and add lang as ts, and then we will just import on mount from Svelte, and then we'll import invoke from our Tauri API that we added, Tauri apps API / Tauri, and we'll add our types. So interface geo, country as string, and latitude as number, and longitude as number. Then we'll add the weather info. So interface weather info with time zone as string and city name as string, then country code as string. Let's use string instead, and dead time as string, temp, which is optional, as number, and then parent temp as number, description as string, and visibility as number. This is the types that we'll need today, the interfaces. Now let's add a few variables, countries as geo, and selected country as geo or null, with, and then weather info either info or null, initially assigned to null, and then error as string or null, and then null. Now let's add on mount. It will just go ahead and fetch the countries with their latitude and longitude. So on mount async and try catch e, and we'll just invoke. So countries is equals to await invoke get geo info and console.log whatever the error is, and error is failed to fetch geo info. Once we have on mount, we'll add fetch weather. So just async function which is fetch weather no params, and if no selected country then we just return, but if there is a selected country then we try weather info await invoke get weather with the arguments that we have to pass, which is latitude and longitude. So selected country dot latitude and long as selected country dot longitude, and here in catch we'll just again console log and copy this from here. Let's use console error instead of log, and failed to fetch weather info. Now let's add selected country. So function selected country event and const selected index event dot target is HTML select element dot selected index, and then we'll just do selected country is equals to, let's name this select country countries of selected index, and then we'll just fetch weather. So this is all the scripts, the functions that we need to add. Now let's add our UI. So I just added all the styling that we'll need. Again, no point wasting time on CSS. I'll just provide all of this in the description so you guys can copy the same styling. So let's add the component div class as container h2 which says select a country, and then we'll just do if error, then we display error. That's why I've been logging and then also keeping the error here, because I wanted to show it on the UI. And else select on change call select country, and which which we have right here, select country, the function. And for each country that we have, each country in each country's as country, we'll just add option with value as country dot country, and will also display country dot country, and that's all the option that we have to add. And let's close each. So once we have select, after select, let's close the if. And now here we'll add if weather info. If we get some valid weather info, then we want to add a div with a class as weather details. And h3 saying weather details for, let me fill these details. So here you go, you guys can just pause and add this, a bunch of p tags and h3 that we just added with all the details shown in a table format. So, and also hard-coded units. If you want to make it dynamic, then you can. And once we have all of these details and our UI ready, now before we run and test our application, go to your project explorer and go to routes, and here the page.svelte, and let's call our component here. So we'll just remove all of this and add a script and import weather from lib/weather.svelte, and let's see the name. Yeah, it's weather. And then we'll just add a h1 saying welcome to weather app beta, and here we will add our weather. So that's all that we need to make changes. So open in terminal and we'll just do yarn Tauri dev. So as you guys can see, it's compile and finish. Now let's go ahead and test our UI. So here you go, the first look of our weather application. Welcome to weather app beta. Let's select a country from drop down. So let's say I selected Italy, and there you go, the weather for Italy. Similarly, if we select Brazil, there is a weather for Brazil. And let's say I select Singapore, there is a weather for Singapore. So that's it for